Hi, have you ever wondered how glass made? Where it came from? For this video, we will tackle about glass manufacturing. Glass is known for its fragility as well as firmness that makes it atypical of a solid. At the same time, it can be qualified as a liquid. But scientifically, glass is what's called an amorphous solid, a state between two states of matter. In terms of conductivity, a glass is neither thermal nor electrical, since it has no reaction with accumulation chemical compounds. Plate glass can be made in two different ways, by rolling method and by floating method. Rolling method. Sand, lime, and soda are heated together in a furnace to make a liquid gas. Rollers are used to flatten glass into sheets, which are first cooled, then cut. Floating method. Liquid glass from a furnace is floated and slowly cooled on the surface of its liquid tin. After the glass has cooled down, it is cut into pieces. Other glass making ingredients: alumina, lead oxide, potassium nitrite, and zinc oxide, plus waste glass. The first record of glass being manufactured goes back to 3000 BC, and since that long time ago, the process is always includes superheating silica or sand, turning into molten glass. Then they blow the glass or pulled it and shape it, and try to turn it into a flat sheet that can be used as windows. Well, in 1950s, a technique was perfect called float gas, and a float glasses how almost all windows in this planet are manufactured now today. Let's see in this video a step by step on how to make a glass. The float process. This is the most advanced and efficient technique to obtain a high quality product. Let's discover this step by step how glass is made by following its journey along the float line. It all begins in the Earth's most abundant raw material. The primary ingredients are sand, lime, and dolomite, soda, and sulfate. Glass itself is also an important ingredient. It recycling reduces the need for raw materials and accelerate the melting process. As a result, energy consumption is limited and less CO2. One of the main greenhouse gases is emitted in the atmosphere. In addition to recycled glass, crushed or broken glass called cullet is added to the mixture. Cullet comes from the both of manufacturing process and customer scrap cuts. The mixture of raw materials used for melting is known as the batch. Its exact formulation varies whether the transparent or colored glass is desired. The various raw materials are transported to the factory by truck or train and are stored in the silos in the batch house. All these raw materials are rigorously checked to guarantee the purity of the batch. Each material is weighted by scale before being delivered automatically into the mixer. This is when recycled glass is added to the batch. Effective batch mixing is key to the melting process. Best glass quality can only be achieved when the batch has the necessary homogeneity. About 4 to 5 tons of batch are conveyed around every 5 minutes to be distributed in the batch charger. During the process, a flat glass ribbon of uniform thickness is formed on a 5-meter long line. The batch charger regularly lays down raw materials at the furnace entrance on a part of the line called the doghouse. The raw material drops on the 1300 degrees Celsius molten glass already contained in the area and are continuously pushed inside. In the melting zone, the batch of mixed raw materials melts at a temperature of 1550 to 1600 degrees Celsius until it becomes liquid and merged. Melting occurs by heat transfer from the flames located above the glass surface. Chemical reaction between the different elements allows the elaborate of high-quality glass free of bubbles. The process within the furnace is continually monitored by technicians who take measurements inside and from the screens in the control room. The flames develop above the furnace. Every 20 minutes, the direction is reversed to optimize the thermal balance in the furnace and the efficiency of the flue gases heat recovery chambers. In the working end zone, to prepare the spreading of the glass over the thin bath, it is cooled down from the 1400 to 1100 degrees Celsius. A cold airflow is regulated for it to precisely reach the temperature and viscosity required at the forming zone. Glass is then ready to leave the melting furnace and enter an enclosed bath of molten tin. At the point of the process, the glass looks like honey. At the beginning of the float bath, glass coming from the furnace flows gently and spreads out. It literally floating on the molten tin to become a continuous ribbon of perfect flatness. The edges of the glass puddles are masked by top roll machines, which acts on the spread surface of the glass. The top roll effect, together with the exit speed of the ribbon, are the two main factors to adjust its thickness and width. In order to optimize the production performances, these steps are monitored from the control room 24 hours a day and 7 days a week. At the end of the float bath, the glass is cooled on further and leaves the tin bath at around 600 degrees Celsius, when it's just solid enough to clamp on the metallic rollers and be driven inside the layer. In the layer zone, the glass is annealed and gradually cooled to relieve inner stresses and prevent splitting in the cutting phase. Cooled down too quickly, it would break. The layer measures from 150 to 200 meters long and is made of two parts. The first one is the annealing zone, where the temperature decreases from 600 to 480 degrees Celsius, and where permanent stress is fixed. This is the critical part of the process to give the glass cutting quality that matches customers' requirements. The second part of the layer is the cooling zone, where, depending on its thickness, the ribbon is gradually cooled to reach the temperature between 50 degrees Celsius and 80 degrees Celsius. At about 300 degrees Celsius, it becomes possible to lock out the downstream area of the line without impacting its upstream part. This can be useful for maintenance purposes. For instance, the operation, called water break, consists in sprinkling water on the surface of the ribbon to create a thermal shock effect that causes the glass to crack and break. Past the water break point, the layer is not covered anymore. The cold end is the last part of the production line. It includes quality control, cutting, and stocking. The entire glass ribbon is continuously checked by a high-performance optical system to detect all kinds of defects. Thanks to the information received by the control system, an automaton maximizes the production of the ribbon with regarding the quality standards. Glass sheets are automatically created by a two-step cutting process in which the ribbon is stripped and snapped along these strips to standard dimensions. The longitudinal stripes are made by a diamond wheel that creates surface defects on the glass. This prepares the ribbon for the subsequent cuts of its edges, thereby removing the top rose marks and obtaining the net width. Then, the transversal stripes will determine the length of the glass plates. In the breakage area, the continuous ribbon is interrupted to form glass plates. The breakage operation consists in a lever effect made by an automatic breakout bar aligned with the transversal cutting line. Next, the edge rulers apply a pressure on the longitudinal cutting line to trim the glass plates. The edges, together with any glass area not fulfilling the required quality standards, go back into the furnace for recycling. The plate thus form and carried by rolls at a higher speed to separate it from the continuous ribbon. These final glass sheets are absolutely transparent and have perfectly smooth surfaces. They are ready to be automatically stocked as calibrated piles of glass weighing from 2.5 to 20 tons. The glass piles are offloaded thanks to special handling machine called transloaders. The glass is conveyed to the warehouse for storage or to the expedition area, ready to be sent to the customers. Glass frames are loaded on special trucks called unloaders. Direct contact with the glass is avoided during the whole transportation. After an approximately 500 to 600 meter long path and a minimum duration of one full day, float gas is produced from natural raw materials and gotten ready for delivery and further processing. Glass widespread use in the architectural and automotive sectors make it a central part of the world we live in. Handmade glassware. Vases, ornaments, and other intricate glass objects are made by a glass blower. The glass blower uses a metal blowpipe which has a blob of a hot glass at the end of it. A glass blower then blows the soft glass into a shape with his hand. Now, let's see how glass is made the artisanal way. Before machine-made plate glass became popular in the 1920s, window glass was blown by artisans. Today, especially companies still make window glass the traditional way, while machine-made glass is uniformly curing flat. This furnish melts silica sand and other natural materials into glass. The starter begins by inserting the end of the blowpipe into the furnace. He takes small amount of colorless molten glass out of the furnace and rotates it in a wood mold. The mold is lined with heavy paper to soften the surface. Then, he inserts a metal needle through the blowpipe to create a pathway for air. He returns to the furnace for more molten glass. The artisans makes multiple trips to the furnace and shaping the molten glass in stages so it's easier to handle. This time, the assistant shaped the glass with a large mold. When the shape is set, the assistant prepares it for blowing. He uses a fork tool to push the glass to the top of the pipe. The starter rotates the glass in a large paper-lined mold around it further. The molten glass cools rapidly once it comes out of the furnace. The temperature dips below 1800 degrees. It's no longer workable, so the team must work quickly and reheat the glass repeatedly. Another assistant lubricates the blowpipe so it rotates easily on a support stand. Starter end the glass over to the master glass blower. First, he rotates the blowpipe to straighten and center the drooping glass. Then he begins turning and blowing into the pipe to gradually inflate the glass. This requires physical strength as well as tremendous artistic and technical skill. The pipe and the glass weigh over 30 pounds combined. When the glass starts to cool, the assistants reheat it in a smaller oven. He passes the pipe back to the glass blower, then resumes inflating it. This time, he swings it upside down using gravity to help elongate the shape. Next, he will transform the glass balloon into a cylinder. First, he reheats the tip of the glass and weakens it with a hot burner. Then, he reheats the entire glass cylinder. This expands the air inside and forces the weakening tip open. The glass blower taps the opposite side of the hot glass with a cold metal stick. The thermoshock causes a heat stress breaking. This releases the glass from the blowpipe. The assistant lies it lengthwise with a glass cutter and hand it off to the flattening team. Their job is to transform this cylinder into a sheet glass. The flattening master's assistant puts the cylinder into a furnace. It heated over 1500 degrees. The glass softened in about 30 minutes. Then, flattening master reaches them to the opposite side end of the furnace with a stick and gently opens the cylinder. The flattening master irons the glass sheet with a special wood tool. The flat sheet goes into the annealing oval for a gradual controlled cool down. This relieves stresses and prevents cracking. The flattening master's assistant removes at last from the annealing oven and perform a visual inspection. The last step is to cut the edges straight. To make multicolor and textured glass, they add additional ingredients during the melting process.